Welcome to our lecture 3 on the production possibility frontier, which is called the PPF. We'll discuss concept of scarcity, opportunity cost, the trade-off, the MRT, the efficiency, and economic growth. So what is a PPF? So a production possibility frontier is an economic model that is used to illustrate the concepts of scarcity, trade-off, and opportunity cost. So the PPF explains the concepts of marginal cost, marginal benefits, efficiency, and how economic growth can be attained. Given scarcity of resources and unlimited ones by economies, a choice has to be made in terms of how resources must be allocated to the production of various goods and services within a specific period. So we're going to illustrate a PPF as follows. So we're going to show how the graph is able to depict the maximum combinations of an output of two goods, assumably two key goods that a firm, an organization, or a country may be producing. So a PPF has a number of assumptions that we must look at. Number one is that the economy must only produce two goods and services, holding other factors constant. The second assumption is that there must be a fixed available resources used to produce either the goods or services. Number three, there must be a fixed amount of technology. Number four, there must be full employment of resources in the least costly way. So a PPF does not only represent the opportunity cost, but also it measures the opportunity cost. So it will demonstrate that there is a limit to what you can achieve. It can also demonstrate that every choice that the opportunity cost gives, you get more of something only by giving up the other. So PPF is generally about outward curve, which shows the available possibilities. So it divides the key spaces available into three. Number one, there are points that will be on the PPF. Number two, there are points that will be inside the PPF. Number three, there are points that will be outside the PPF. So these points have the following connotation. So when you're dealing with the PPF, we're going to look at three key points. Number one, points on the PPF. So we have point A and point B. This is when we are utilizing the resources at the maximum possible. And point inside, this is when we are not utilizing the resources. And points outside, this is when we cannot attain it. So we have goods Y and X. So for us to move from good A to good B, for instance, this is 4 and this is 3. We need to lose 1 unit of good Y, gain 3 units of good X. So we call this a trade-off or opportunity cost. So by losing 1 unit of good Y, we're getting 3 units of good X. At point C, we're underutilizing our resources. We're being inefficient. At point D, we're being a well-wisher. It's unattainable because we're dreaming of what we want to achieve, which we can only achieve by expanding the economy through technological advancement. We must also understand that if an economy is unproductive, it can also shrink down to even C. That is when we are not fully employing our resources. So basically, the concept that the PPF brings about is that there are points that are inside the frontier. These points at the current resources simply imply that we are being wasteful. There are also points that are outside the frontier, which are unattainable. At the current level of resources and technology, it means that the current economy needs or desires improvement. So because of scarcity, PPF gives us options available. So the slope of the PPF is always negative, reflecting the concept of a trade-off. The trade-off is simply an illustration of how much must be given up. So this is a slope which illustrates how much must be given up of one to attain the other. So if we're going to work in vice versa, if we're going to lose 2 units of good X, we're going to get an additional unit of good Y. This is the trade-off, the cost of giving up one for the other. So the PPF shows the opportunity cost of one good forgone measured in terms of the other. It is represented by the slope of the PPF. So opportunity cost can either be constant, which is a linear PPF, or increasing, which is bowing outwards. So we must consider an economy that produces computers and cars. So the PPF for this economy can be illustrated with a graph using a linear version. So if we're going to be given such a picture and we are told that the slope which we have here, we have computers here and we have cars there. So we have 3,000 and we have 1,000. So the slope is a change in Y over change in X. So we can 0 from 3,000, 1,000 from 3,000. We can calculate the slope by dividing the differences there. So expect calculations to come from these illustrations here. So 3,000 minus 0. Okay. 0 minus 1,000. So here we're going to have what? 3,000 over negative 1,000. So the slope here will be what? -3. Meaning we're going to give up 1 for the other. It's usually negative because of the concept that we are foregoing 1 from the other. So the slope of the PPF measures the opportunity cost of producing good X in terms of Y. So if the PPF is linear, the opportunity cost of X in terms of Y is constant at all levels. So this also implies that the resources that are used in production of cars are just as efficient as that of computers. So this, however, is unrealistic because the linear PPF are easier to deal with. So in this case, we can calculate the slope at any of these points, we still get the same amount, which is -3, like I explained to you. So this means that the marginal rate of substitution of Y for X is -3. So meaning of every 1 car, you're going to forgo, you earn 3 computers. So these are computers and these are what? These are cars. So if we're going to reduce from 1,000 to 0 cars, we're going to earn 3,000 computers. Or if we're going to reduce from 3,000 to 2,400, so at this point here, we're moving, you can still get the same answer here. So at this point, from here to here, we're going to subtract 3,000 minus 2,000 what? 400. And here, we're going to have 200 minus what? 0 minus 200. So this is what? 600 divided by -200. We're still going to get -3. So this is how we calculate the opportunity cost. So the PPF shows choices. Choices of combinations that may also come. For instance, a combination of kidney cancer treatment. There are health conditions that will give you a choice that you need to make, either to save the child or to save the mother. So these decisions that are made also made in different categories. It can be in health, it can be in business. So when we are dealing with the National Health Council, can provide kidney care treatment and no other services. Can also provide healthcare services and no kidney services. So any of the combinations between A and HKA could be provided. So these decisions stream from a number of choices. So opportunity cost, therefore, must be made in making up the decision that would be optimal. So you must weigh the benefit or the loss. So a scenario can be given, for instance, where you're given having to invite more guests, meaning the number of flowers must also be considered. So we must either, so in this PPF, we are making a decision of how to use resources. One has to choose choices A, B, C, D up to G, depending on how much they want to spend on flowers as opposed to how many guests they want to invite at the wedding. So you can use the PPF to illustrate your decisions of options. So if you're given this, we're going to illustrate. So this is 0, you draw in your scale. So your guests are here, you can denote this as G, and your flowers are here, denote this as F. So you have 0 at 120, 100 at what? 100. Then we go to 200 at 80. We have 60 at 340, 420, 500 and 0. So this is our linear PPF. So now we'll be asked to calculate what is our opportunity cost, what is our trade-off. So we can use, well, this linear assume that at every point the slope is the same. So this is 120 minus what? 0 divided by 0 minus 600. So you're going to have 120 divided by negative 600. What do we get? What do we get? 120 divided by 600. So we're going to get 0.2 negative. Okay. So the opportunity cost of guests for flowers. But if they're asking you opportunity guests of flowers for guests, you can start from here. 600 minus what? 0 over 0 minus what? 120. So this is 600 divided by negative 120. So when you divide that, you're going to get 5, negative 5. So now we need to understand, in this scenario, we're being asked what is the opportunity cost using the curve on how much must be forgone with the limited resources for having guests at the expense of flowers. So I've given you the computation here. You will need to calculate the marginal rate of substitution of one for the other. So this is how the PPF is illustrated. So you can also have a bell-shaped arrangement where all points that are inside the frontier are attainable. So A and B are attainable, except that A shows an efficiency. C is unattainable because of scarcity. Resources here are bounded. So we can only reach C if we increase our technology. So inefficiency is simply getting the most. Efficiency is getting the most out of what? The outputs. And efficiency is getting less from the inputs if we devoted time to other activities. So to analyze this PPF, all points on the PPF are attainable. They depict efficient resource allocation. Point A, on the other hand, is attainable, but we are being wasteful. We are underemploying, we are being inefficient. So you must understand that the PPF depicts the decisions and choices that are being made. So A is inefficient, B is efficient, and D is unattainable given the technology and the resources that we have. So we must be able to understand the concept that is depicted by the PPF. So looking at this example here at B, we have what? 800. At B1, we have 800 cars and 1,500 computers. So if we want to increase the number of computers to 2,000, so what we do, we are going to apply opportunity costs. So we're going to give up a certain number. So B to B2, we're moving to this direction. So we're going to have what? 800 minus 600. Then we are going to have 1,500 minus what? 2,000. So here this will be 200 over 500 negative. This is 0.4. So to increase the number at point, so if we want to increase the number of computers to 2,000 at point B to B2, we are going to be producing 2,000 computers, but only 600 cars. So to increase, we are going to increase production of computers by 500. But this means that we're going to give up how many? 200 cars. So this 200 is opportunity cost that we have. We're giving up how many? 200 cars. So we're going down by 200 to increase our production from 1,500 to 2,000. So we're going to have a negative slope of the PPF. So we must understand that we are giving up the other good. So that is a computation. So the slope is the opportunity cost itself. Any questions so far at this point? So what is opportunity cost of increasing production from 1,500 to 2,000? The opportunity cost is 200 cars. So we're giving up 200 cars to increase production by 500. Try together. Are we together?
Yes.
Any questions so far? All right. So another example we have here, the slope that we have here from point A. So from here to here, so we're increasing y by 2. From here to here, we're decreasing x by 1. So we're going to therefore have a slope of -2. So it's a change in y over the change in x will be 2y over 1x. So 2 into y is simply 2. So in reality, the change in y will be what? 6 minus what? 8 over distance from here to here. This is 2 minus 3. So here this is 2 over 1 is -2. So that's the slope that we are looking at. So we need to understand how to compute opportunity cost for each of these ones here. So basically, this is a concept that I want you to understand on marginal rate of technical substitution. So the slope of the PPF is actually called marginal rate of substitution, or others call it the marginal rate of transformation. So the PPF, which is linear, may give you the marginal rate of transformation X for Y or Y for X, depending on what has been given. So if you're asked to say, we're given a budget line, suppose the budget line is 100 and the price of good X is 10 kwacha and the price of good Y is 20 kwacha. Let's write the budget line. So our budget line is given by I is equal to the price of good X times X plus price of good Y times Y. So what is our budget in this case? 100. And our price for good X is 10. So we're going to put 10X. And what is the price for good Y? Is 20. 20Y. So this is what we call the budget line. So how do we sketch the line? We're going to find the intercepts. What number is before the X? It is a 10. 10 into 100, we get 10. What number is before the Y? It is 20. 20 into 100, it is 5. So this is how we draw the budget line. Our Y will cut on the 5, and our X will cut on the 10. So this is how the budget line is. So our income or the budget line is equal to 10X plus 20Y. All right, so the slope usually is given by the price of good Y over price of good X. Price of good X over price of good Y. What is the price of good X? 10. Price of good Y is 20. Negative. So we're going to get a 0.5. That is how we compute the slope. Let's try another one. Suppose you're given a budget of 80 kwacha and the good X costs 2 kwacha and good Y costs 4 kwacha. What is the budget line going to be? 80 is equal to 2X plus 4Y. So we divide 2 into 80. We're getting 40. Then 4 into 80, we're going to get what? 20. So how do we draw the budget line? Y is here and X is there. So we're going to draw the line. On the Y, it will cut at what? 20. And the X, it will cut at what? 40. That is the simplest way we're going to draw the budget line. So this will be 80 is equal to what? 2X plus 4Y. All right. Now, we may be asked, therefore, a question to say, suppose you want to consume 20 units of what? Of good X. How many units of good Y are you going to consume? So, where there's X, we're going to put 20. So 80 is equal to what? 2 times 20 plus 4Y. So here 80, here we're going to have 40, then here we have 4Y. So when this one goes side, it will subtract. So this side we're going to have 80 minus 40, which is 40. And here we're going to have 4Y. So both sides divide by 4. So meaning Y, therefore, will be what? 10. So to consume 20 units of X, we're going to consume what? 10 units of Y. So any movement along this curve is called marginal rate of substitution if we're going to forgo one for the other. Any questions?
Yes, I've got a question. So kindly explain again on the budget.
So the budget
Budget
line
line.
is given by
Yes.
income is equal to the price of good X times X plus price of good Y times Y. This is what we call a budget line. Whereas I stands for the income, PX stands for the price of X, PY stands for the price of Y. So in an event where you're given to say, suppose we have an income of 1,000 kwacha, and we are told price of good X is 10 kwacha. The price of good Y is 50 kwacha. What becomes our income equation? 1,000 is equal to what? 10x plus 50y. Are you together? Or coming up with the budget line? Because the price of good X was 10 kwacha and the price of good Y was 50 kwacha. Are you together?
Yeah, I'm okay now. Thank you.
So now you'll be asked to plot it so that we illustrate it. So we're going to identify the intercepts. So 10 into 1,000, we're going to get 100. 50 into 1,000, we're going to get a what? A 20. So we know that Y is on this axis and X is on this axis. So if we're going to draw this line to cut the Y-axis at 20, to cut the X-axis at 100. So this is our curve for the budget line. So 1,000 is equal to what? 10x plus what? 50y. Now we must understand that the behavior that emanates from the consumers is as follows. Suppose with the very budget line here, our income doubled to 2,000. The rest remained the same. Price of good X is 10, price of good Y is 50. What would happen? 10 into 2,000, we get 200. 50 into 2,000, we get 40. So the implication of the increase in income will cause the budget line to shift outwards. So meaning you're going to be able to afford more units of good Y and good X. So you're going to double here, you're going to have 40, you're going to have 200. Similarly, if you halved this from 1,000, it went to 500. What would happen is that good X, you only afford 50 units, and good Y, you're going to afford only 10 units. So it would shrink inwards. So the budget line will be inside here. So here we'll have maybe a 10, and here we'll have a 50. So this is what happens when income is manipulated. But in the instance where good X becomes cheap, instead of having 10 kwacha, you're going to have 5 kwacha there. The budget line will still remain the same, but here we're going to put 5x. So by good X becoming cheaper, it means we're going to afford to buy more units of good X. So we're going to cause a tilt. On the X-axis, it was initially cutting from 20 to 100. But now since good X has become cheaper by half, we're going to double. So meaning our consumption on X will be what? From 100 to 200. So this is called a tilt. So we're going to tilt outwards. If good X became more expensive, instead of 10 kwacha, it was now 20 kwacha. Meaning you're going to afford few units of good X. So meaning it will be tilting inwards. So we're going to afford less of good X and to tilt inwards. Maybe we're going to afford only 50 units of good what? Of good X. So what am I saying? These pictograms here we're seeing here illustrate 4 key conditions, if not 6. So if the budget increases and it doubles, it will cause our equation to shift outwards. This means that what? The budget has what? Increased. If the budget decreases, what will it cause? It will shift inwards, meaning we're shrinking the ability to spend. Our purchasing power goes down. Are we understanding? Are we following? On the other hand, if good Y becomes expensive, meaning we're going to afford less of Y, so it will tilt inward. That's on Y, meaning X is remaining the same. So if Y becomes cheap, meaning we're going to tilt outwards. So meaning we're going to tilt outwards there, meaning if we're affording only 4 units of good Y, we're going to afford maybe 8 units. This is when good Y becomes cheap. Even with X, when X price goes up, meaning we're going to afford less of X, so it will mean we're going to tilt inwards on X. So X will reduce from a huge consumption to a low consumption. Lastly, if X becomes what? Cheap, meaning we're going to afford more of X, so meaning the tilting here will happen outwards there. So with this that I've explained, the next class, we're going to now explain how questions will come to that effect. Unless any questions, will end here.
So the formula for the income, that one is fixed. We just need to master it, isn't it?
Yes, income. This is how the budget line comes in. So although income is denoted by a number of letters, income can be denoted by letter Y, by letter M, by letter Y. So this is also the income equation. So I've compiled a pamphlet for you guys in case you want to buy question and answers that could help you tackle some of the questions that may prepare you for the exam. Otherwise, this is on the first unit and the third unit.